All right, so if you've spent any time in AWS, you've definitely heard of the application and network load balancers. They're famous for a reason. But today, we're going to talk about their kind of weird, specialized sibling, the AWS Gateway Load Balancer. And trust me, this isn't just another flavor of load balancer. It's a completely different beast for a really critical job. Let's dive in.
First things first, let's get one thing straight right off the bat. Your ALB and NLB, their job is to handle traffic, to spread it out across your applications. The Gateway Load Balancer, or GWLB, couldn't care less about that. Its entire reason for being is not to handle traffic, but to inspect it. That's the key. That's the fundamental difference that changes everything. And to really let that sink in, here's the one metaphor you need to remember. Think of all your network traffic as cars zipping down a massive digital highway. Well, the Gateway Load Balancer is a mandatory pull-over right now security checkpoint. Every single car, every single data packet has to go through this checkpoint, get scanned by security, and only then does it get to merge back onto the highway and continue to its original destination. So, with that image of a security checkpoint locked in your head, let's really get into it. Let's break down what this thing actually is, and, more importantly, why it's become so essential for serious cloud security.
Okay, so technically speaking, the GWLB is what we call a bump in the wire service. It lives at layer 3, the network layer, which is all about routing, and the magic word here is transparent. What this means is you can stick a whole fleet of security appliances right into the path of your traffic, and to the outside world, nothing has changed. Your apps, your users, they have no idea this inspection is even happening. The source and destination are completely untouched.
So, an invisible security checkpoint. How on earth does that actually work? It sounds a little like magic. So let's pop the hood and see what's really going on with a packet as it goes through this process. It's actually a really elegant 5-step flow. First, your traffic hits a Gateway Load Balancer endpoint. Then, step 2, the GWLB wraps up that original packet using a special protocol called GENEVE. We'll talk more about that in a sec. Third, it sends that wrapped up package over to one of your security appliances. Fourth, the appliance does its thing, inspects it, scans it, and sends it right back. And finally, the GWLB unwraps the packet, revealing the original, and sends it on its way as if nothing ever happened. Now that GENEVE protocol I just mentioned, that is the absolute secret sauce. It's an encapsulation technology, which is just a fancy way of saying it puts the original packet inside another packet. By doing this, it perfectly preserves all the original information, the original source IP, the destination, everything. This means your firewall gets a perfect, crystal clear picture of the traffic it's supposed to be inspecting. But hang on a second. What if you have a whole army of firewalls? How does the GWLB make sure that, say, all the packets for your video call go to the same firewall? You don't want them getting mixed up. Well, that's where something called the 5-tuple hash comes in. The GWLB looks at 5 pieces of info, the source and destination IPs, the protocol, and the source and destination ports, and creates a unique fingerprint for that conversation. This ensures that every single related packet sticks to the exact same security appliance, which is absolutely critical for stateful inspection.
Okay, the tech is definitely cool, but what's the point? Let's move from the what and the how to the why. Where does this tool actually fit in the real world? The number one reason you'll see a GWLB is to deploy fleets of third-party virtual appliances. We're talking about those big-name firewalls from Palo Alto, Cisco, Checkpoint, you name it. This lets you build what's called a centralized security VPC. Instead of trying to manage firewalls in dozens or hundreds of different VPCs, you just funnel all their traffic through this one central hub for inspection. It makes management a breeze and keeps your security policies consistent everywhere. Now, as powerful as this all sounds, the Gateway Load Balancer isn't a silver bullet. Like any tool, it has some incredible strengths, but also some really important limitations you have to know about before you start building your architecture around it. The advantages are huge, let's be clear. First off, you get automatic scaling and high availability. One of your firewalls goes down, the GWLB just stops sending it traffic. Simple as that. Need more capacity? Just add more appliances. Second, that transparency is a lifesaver. You get to avoid all the architectural nightmares that usually come with network address translation or proxies. And of course, the big one, consolidation. One place to manage security for your entire organization. But on the flip side, there are some hard rules. For one, everything has to live in the same AWS region. There's also a pretty firm bandwidth limit on each endpoint, which we'll hit in just a moment. Historically, it's been an IPv4 first service, and that GENEVE encapsulation that we love so much,
it does add a tiny bit of network overhead. It's small, but it's there. And about that bandwidth cap, here is the number you need to burn into your memory: 40 gigabytes per second. That is the absolute maximum that any single gateway load balancer endpoint can push through. Now, for most of us, that's a ton of bandwidth, but if you're running a really high throughput workload, this becomes a critical part of your design plan. You've got to account for it. Okay, so this brings us to probably the most common point of confusion out there. You've got a network load balancer, you've got a gateway load balancer, they sound kind of similar. When on earth do you use which one? Let's put them head to head and clear this up for good. Look, this table really says it all. The number one difference is purpose. Are you trying to inspect traffic or distribute traffic? If it's inspection, you want GWLB. If it's distribution, you want NLB. Simple as that. They also operate on different layers of the network, and they use totally different technologies under the hood. That GENEVE encapsulation for the GWLB versus simple direct routing for the NLB. They're just different tools for different jobs. So we'll end on this thought. When you think about its power, the ability to transparently insert a scalable, highly available fleet of best-in-class security tools right into your network, you have to ask the question, has the gateway load balancer become the new default, the new standard building block for any enterprise that's serious about cloud security and compliance? It really, really makes a strong case. Thanks for joining me.